This video is going to cover the surface area of prisms, cylinders, and spheres. We're going to talk about the formulas for all three of those shapes, and we are going to use them to calculate surface area for some different figures. You should have a copy of the notes. Should look like this. Should say Unit 10, Lesson 3, surface area. And you're going to need an extra sheet of paper. If you want to get some highlighters to color code some things, you can do that. I'm not going to color code my notes. If you want to see color coded notes, watch Miss McCulley's video from her website, and she'll have everything color coded if the black and white is kind of making it hard to visualize what's happening. So when we do surface area of prisms, cylinders, and spheres, they all start with the same basic generic formula. They all start with this formula that says surface area equals the lateral area times 2 times the base. So we have to then figure out what the lateral area is of our shape, and then we have to use the formulas that we know from middle school for rectangles, triangles, and circles to find the base area. So let's talk about what these things mean for just a second. So I've got a chapstick here because a chapstick is a cylinder. So when we talk about the lateral surface area is this outside part that wraps around. So the wrapper that was on this chapstick, that's on it now and that went all the way up onto the lid, that was the lateral surface area. To calculate how big that needed to be, they had to calculate how big just this outside space was so that they could wrap the wrapper around there. Now, if we wanted to wrap the entire thing, we wanted to wrap both ends and the entire lid, that's where this 2 times the base comes in. So the base is the shape. So this is a circle. We got a circle on each end. And if we wanted to wrap not just the outside edge, like all the way around, if we wanted to wrap the top and the bottom, we would need to know the area of that base. And there are 2 of them, one on the top and one on the bottom. So that's why we do 2 times the base. So to do lateral area, you have to have 2 things. You have to have the perimeter of the figure, and you have to have the height of the figure. So when we talk about perimeter, we're going to talk about like just the perimeter of the rectangle or the perimeter of the triangle. When we talk about the height, we're going to talk about how far apart the 2 bases are. So how far is it from one rectangle to the other? How far is it from the top of the cylinder to the bottom of the cylinder? And then we're going to use those formulas, like I said, that we learned in middle school to find the area of the base. So let's look at our 3 that we're going to focus on right now today. We're going to look at a rectangular prism. So a rectangular prism has a base that is a rectangle shape. So it's a little bit highlighted on here already. It's a little bit shaded in. I'm going to shade in. I'm going to use this end and I'm going to use this end as my base. Now the thing with rectangles is that there are a lot of different bases. So you kind of have to choose which one you want to be your base and pick numbers based on that. So I'm going to shade this space in, and we're going to have to calculate our lateral area. So our lateral area is the perimeter of this rectangle times the height of the entire prism. So we would calculate the perimeter of this shaded in spot right here on the end, and then we would want the distance from this end to this end of the prism. And then we're going to say plus 2, and to find the area of a rectangle, we just do length times width. So the formula that's specific to a rectangular prism is P times H plus 2 times length plus width times width. When we look at a triangular prism, we should find 2 triangles that are parallel to one another. So I got a triangle here and I got a triangle down here. Those are my bases. So to calculate the rectangular prism, you're going to have to find the perimeter of one of those triangles, and you're going to multiply that perimeter times how far it is from the first triangle to the second triangle. That's what that height is. And then we're going to do the area of the base. The base is a triangle, so we're going to say 1/2 the base times the height. Just to keep from getting confused, I'm going to make kind of a fancy H right there when we're talking about the distance between the ends of the figure. For a cylinder, we want to find the perimeter of a cylinder. Well, the perimeter of a cylinder isn't just, hey, add up all the sides. The perimeter of a cylinder is a little bit different. It is a formula for circumference, because there's a fancy word for perimeter of a cylinder. So what we would do is we would write that in. The formula to find the circumference of a cylinder, or the circumference of a circle, is 2 pi r. And then we're going to multiply by how far it is from the circle on one end to the circle on the other end. And then we're going to add 2 times the area of the base. Well, the formula for the area of a circle is just pi r squared. So these are the 3 formulas that we're going to use. We're going to do a lot of examples. We're going to do a lot of examples of each one. We're going to do a lot of examples with missing pieces of information that we have to calculate for. So let's do this. So you've still got this note sheet. Let's number this note sheet because it's not numbered. And just so that when we write down the formulas on our separate sheet of paper, we know exactly what we're doing. I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 figures on this sheet. As you get into this, how detailed your notes are is up to you. These first 3, maybe 4 or 5, maybe 6 figures, you really need to take really good detailed notes, okay? So make sure that if I write it down on these first ones, that you write it down. So I'm going to try to keep everything on the screen together. It's going to be a little harder as we get down the page. So our first picture is a cylinder. We know it's a cylinder because it has a cone on either end and it's got a height to it. So we want to use the formula for cylinder. So we're going to say surface area equals 2 pi r. So 2 pi r times how tall the cylinder is plus 2 times the area of a circle. And then we want to plug those numbers in. So this is our radius. This is our height. Cylinders are pretty simple because they don't have a lot of numbers that you have to fill in. So we're just going to plug those numbers in. 2 pi, we're going to replace the r with a 3. We're going to replace the h with a 9. 2 pi, we're going to replace the r again with the same 3, and we're going to square it. Make sure you don't forget to square it. Now here's where surface area becomes really simple. Once you've put all these numbers in the right spot in the formula, you can take this entire formula just like it is and plug it into your calculator. Let's clear all the junk off of my screen here. And we're just going to start at the beginning. 2 pi times 3 times 9 plus 2 pi times 3 squared. So make sure that what you have on your screen looks exactly like what you have on your piece of paper. Got a little light there that's giving you a little glare on my screen. So once all that's in there and it matches up, all you have to do is hit enter. Now, we're not going to write this entire thing. I'm going to round to the nearest tenth because that's kind of where we generally do this. So 226.2, and this cylinder was measured in centimeters, and we're doing area, surface area, so it's centimeters squared. Pretty basic, pretty straightforward. You just have to make sure that you, as you get into pictures that have lots of numbers in there, that you know exactly which numbers you need. And that's where having a highlighter or circling and labeling things before you get started is probably a really good idea. So our second figure has a triangle here, and parallel to that triangle is another triangle just like it. So this is a triangular prism. So for a triangular prism, we're going to use this formula right here. The nice thing about the surface area formula is the first 2 letters never change. It's always the perimeter times the height. And then you're going to add 2 times whatever the shape is. So this is a triangular prism. So we're going to do 2 times 1/2 times the base times the height. Sorry, something in my way there. I had to get it out of my way. All right, so let's talk about the perimeter. The perimeter is of the base. It's of this triangle here. So we need the 3 sides that make up this triangle. So This leg is 3.6. This leg is 4.8. And this, which looks like a hypotenuse, it's not labeled here, but it's labeled down here on the other end. So that's the length of our other side. So we're going to say the perimeter is 3.6 plus 4.8 plus 6. And then we're just going to add those numbers together. And you should get 14.4. So that's our perimeter. And then we want to multiply by the distance or the height between the two triangles. So I got a triangle here, I've got a triangle here, and the distance between those two is this right here. So this is my fancy h. This is my height at 8.5. Then we've got plus 2 times a half. And then we need the base and the height of the triangle. So you're going to go back to that triangle that we used when we were doing the perimeter, and you're going to use the two sides that make a 90-degree angle. So this and this, the 3.6 and the 4.8, we can call this the height of the triangle. We can call this the base of the triangle. You could reverse it. All that matters is that the base and the height of a triangle meet at a 90-degree angle. So we're going to say times 3.6 times 4.8. And then we're going to plug all of that into our calculator. So we're going to start 14.4 times, parentheses, 8.5 plus 2 times, and I'm going to use 0.5 just because it's fewer buttons to hit. If you want to use alpha y equals and do a 1/2 that way, feel free to do that. I just like to use 1/2 because I'm lazy. So 1/2 times 3.6 times 4.8, and we want to close those parentheses that we opened right there. So all of that matches what we have on our paper right here. So we're going to hit enter, and we're going to find that the surface area of that triangle is 139.7. Remember, we're rounding to the nearest tenth right now today. And it's measured in inches, and it's area, so it's squared. Let's look at our next figure. Our next figure is rectangular. And you could call it rectangular, you could even call it square. It just depends on which side you pick as your base. When I look at a prism like this, I like to just look at the side that it's sitting on, and I shade it in so that I can see it good, and I call that my base. And I know that this is my base, and it's parallel to a rectangle that looks exactly like it up here at the top. So we're going to use the formula for a rectangular prism. So we're going to say the surface area equals the perimeter of the base times the height of the figure plus 2 times, now we're going to put the area of the base here, and since my area is a rectangle, we're going to go length times width. And then we just need to plug the numbers in one at a time. So the first number that we come to is our perimeter. So we got to calculate our perimeter. We're going to say perimeter equals, and remember, for a rectangle, just add up all the sides. Now, in this picture, all of the sides are not labeled, but I know that it's a rectangle. And if this side is 18, then this side is 18. If this side is 5, then this side is 5. And so I can say 18 plus 18 plus 5 plus 5. And I'd put all of that in my calculator to get that my perimeter is 46 inches. So I'm going to put 46 for the perimeter. And then this H is how tall is my prism. So how tall is it? How far is it from the rectangle on the bottom to the rectangle on the top? It's 5 inches from one to the other. So I'm going to plug that in. Plus 2 times. I'm going to use the same length and width that I used to find my perimeter. Otherwise, I've done something weird because it's all from the same rectangle. And I'm going to plug all of that into my calculator. 46 times 5 plus 2 times 18 times 5 again. And we find that, did I leave a number out? Oh, I put in the wrong number. 46, not 45. 46 times 5 plus 2 times 18 times 5. There we go, 410. So this particular, so if we were going to wrap this box to give it as a gift for somebody's birthday, we would need 410 square inches of wrapping paper to wrap that box. All right, let's look at another cylinder. So let's look at number 4. So number 4 is a cylinder. We have the height. We know that from one circle to the other is 13 feet, and we know that the distance across is 12 feet. But that's not the number I want. So when I do things with circles and cylinders, surface area equals, we want to do the circumference of the circle, so we do 2 pi r times how tall the cylinder is, plus 2 times pi r squared for the area of the circle. So when we look at this, I don't have a radius. I have a diameter. This is not the number that we want to use. We want to take that 12 and we want to say 12 divided by 2 is 6. So my radius is 6 feet. And this is the number that we want to use. So we're going to plug everywhere there's an R, we're going to plug in that 6. And everywhere there's an H for how tall the figure is, we're going to plug in 13. So 2 pi times 6 times 13 plus 2 pi times 6 squared. Now when I plug this into my calculator, I always use the pi button. There's no hard and fast rule about which one you have to use, about whether you have to use the pi button or whether you should use the just 3.16. Read the directions. Sometimes the directions will tell you to use pi. Sometimes the directions will tell you to use 3.26 or 3.16. Please don't ever use 3.26. So just read your directions. There is a little bit of a difference sometimes if you use the pi button versus using 3.16. It's not a really big difference, but there's a little bit of a difference. So I've plugged in 2 times pi. Now, I don't have to put anything in between pi and a number. The calculator understands that 2 pi means 2 times pi. So 2 times pi times 6 times 13 plus 2 times pi times 6 squared. Got what's on my paper and my calculator. Hit enter and I find that if I wanted to wrap that entire cylinder up to make a confetti cannon, I would need 716.3 feet squared of paper. Number 5 is also a triangular prism, just like the one right above it. And if you'll notice, there's a triangle here, and there's a triangle here. So when we write the formula, we're going to say the surface area is the perimeter of the triangle times how far apart the two triangles are, plus 2 times, and then we're going to use the formula for the area of one of those base triangles. So the first thing we have to do is we have to figure out what our numbers are that we need. So this triangle has numbers and it's kind of hard sometimes to tell what's labeled as what. So this 4 is the space along the bottom of the triangle. This 3 is this right here in the middle where they've made a 90-degree angle. So this 3 is going to be the H of our triangle. Okay, that's the height of our triangle. This 4 is going to be the base of our triangle. So that's not even what we need right now. We've got to find the perimeter. So to find the perimeter, we have this 4. So we're going to say 4 plus. And we're going to make an assumption that we don't generally get to make, but I think we're safe in making it, that this is an isosceles triangle. So if this side of the triangle is 3.61, then this side of the triangle is also 3.61. So those are the sides of our triangle. We want to add those together and you get an odd number of 11.22. I don't, when I'm adding things together, because they gave me 2 decimal places, I'm going to leave it as 2 decimal places when I do my perimeter. Don't round things until the very end. Try to keep as many decimal places as you can until you get to the very end of the problem, and then round your final answer. That'll give you the most exact answer that you can calculate with the information that you have. So this h is the distance between these two triangles. These two triangles are 11 yards apart. So my perimeter was 11.22, my height is 11, and I'm going to say plus 2 times 1/2. And we labeled the base of our triangle as 4, and the height of our triangle as 3. Remember, the base and the height of a triangle have to be found by looking for a 90-degree angle. So sometimes what they have to do to give you the height of a triangle is they have to drop a line and make a 90-degree angle and show you where it's at to tell you what the height of that triangle is. And then we're going to take those numbers, we're going to plug them into our calculator. 11.22 times 11 plus 2 times, remember I'm going to use 1/2. I'm going to use 0.5 instead of making a fraction, times 4 times 3. And we find that our triangular prism has a surface area of 135.4, and it was measured in yards, so we're going to say yards squared. Anytime we do area, surface area, just area of a figure, we're going to do squared. All right, last big one right here is number 6. So number 6 is a rectangular prism. I'm going to use, this time I'm going to switch it up, and I'm going to use the ends here. I'm going to use this end and this end as the base of my figure. So the formula is still the same. The formula is still surface area equals the perimeter of the figure, of the base, times the height of the figure, plus 2 times, and since we have rectangles on either end, we're using length times width. So let's calculate the perimeter first. Perimeter equals, and if we're using this end and this end, the measurements for that are 4 along the bottom and 7 along the top, going up. And then, so we got another 4 and another 7. So we can say 7 plus 4 plus 7 plus 4. And when we add those things together, we find that, let's see, 7 plus 4 plus 7 plus 4 is 22. So we get 22 here. So the perimeter of the base is 22, and the distance between those two bases is 13. And then we're going to add 2 times the area of the base. So if this end is my base, the length and the width are 4 and 7. Remember, it doesn't matter which one's length matter or which one's width. Just got to get them both in there. And then we're going to put in our calculator. 22 times 13 plus 2 times 4 times 7. So we end up with a total surface area of 342 yards squared. Now, we've done 2 examples of everything. We've done 2 examples of cylinders. We've done 2 examples of triangular prisms. We've done 2 examples of rectangular prisms. If you feel comfortable with what we've done so far, you can stop here. If you would like to just see a few more problems worked, hang with me for a couple more minutes and we're going to work the last 4 problems on the page. All right, let me get a piece of paper here. So much noise today. All right, so we've done number 6, so we skip down here to number 7. So number 7 is a cylinder. So we're going to use the formula for a cylinder. We're going to say the surface area equals 2 pi r, that gets our perimeter, times how tall the cylinder is, plus 2, because there's one circle on the top and one circle on the bottom, pi r squared. This one's super straightforward. This is our radius, this is our height. So all we have to do is plug those in. 2 pi times 2 times 10 plus 2 pi times 2 squared. And then we just put all of that in our calculator. 2 pi times 2 times 10 plus 2 pi times 2 squared. And so we find out if we wanted to cover that entire cylinder with rhinestones, we need 150.8. What did we measure? Oh, it's not a measurement given, so we're just going to say units squared. Don't know what those units are, but we want to indicate that we understand that this number is an area, and so we're going to put units squared to show that. Number 8. Number 8 is a triangular prism that sometimes is difficult for people just because of the way that it's sitting, and it kind of throws people off. But what you need to realize is you've got a triangle down here at the bottom. You've got a triangle up here at the top. So that's what makes it a triangular prism. So this number right here is the distance between those two triangles. So that's going to be our fancy H. So when we write our formula, surface area equals the perimeter times the height of the figure plus 2 times the area of the base. So our base is a triangle, so we're going to do 1/2 the base times the height. So let's get our pictures back out here. First thing we want to do is we want to do the perimeter. So we got to do the perimeter of a triangle, so that's adding 3 things together. We've got 2 legs right here. If you didn't see it, look again. There's a little corner right here that says that this is a right triangle. And we're going to use those 2 sides, the 8 and the 6, 8 plus 6. And then the hypotenuse for that right triangle is labeled up here on the other end. So we're going to put plus 10 up there. And we'll add those together. 8 plus 6 plus 10 is 24. So that gives us the perimeter of the base of our figure. And we've already labeled the distance between those two. So that's 4. And then we're going to say 2 times 1/2. And then remember, base and height of a triangle have to make a 90-degree angle. So we're going to use that 8 and that 6 as our base and our height. So let's plug this into our calculator. All right. So we've got 24 times 4 plus 2 times 1/2 times 8 times 6. So we've got 144, and that's measured in kilometers. So 144 kilometers squared. That is a giant triangle. I don't know what would be that big, actually. So I got no idea what to tell you about what you would be covering that's that big. Let's look at one more rectangular prism. So number 9 is a rectangular prism. And everybody likes to go, well, that's a square because everything is 3. Yes, it's a square. A square is a special kind of rectangle. That's all it is. A square is still a rectangle, so I can call it a rectangular prism. And I can use the same formula, perimeter of the base times the height of the figure, plus 2 times the length times the width. It's not anything special. It's just a square and a rectangle are related to one another. So let's go and let's look at this. So we need to start with our perimeter. Let's pick what we want our base to be. I'm going to do this. I'm going to pick this one right here and this one right here. Not that it really matters which one is your base because they're all 3 by 3. So, but I still like to know which one's which. So if I'm going to do the base, the area or the perimeter of the base is all 4 sides. So 3 plus 3 plus 3 plus 3 gives us 12. So the perimeter of the base is 12. The height, so the distance from this base to this base is 3. And we're going to say plus 2 times the length and the width of that base. We're going to plug that whole thing into our calculator. We're going to say 12 times 3 plus 2 times 3 times 3. So that one is only 54 yards squared. Not a very big cube. All right, last example that we want to look at is one more triangular prism, because triangular prisms just seem to be that thing that people get hung up on. I think it's because triangles can be isosceles triangles, triangles can be right triangles, triangles can be obtuse, they can be acute. There's just so many different kinds of triangles that people kind of struggle with them when they see them as a prism. So what we're going to do here is we're going to use this triangle down here on the bottom, this triangle over here on the top. Those are our bases, and we're going to say the perimeter of the base times how far apart the bases are, so the height of the prism, plus 2 times 1/2 the base and the height of the triangle. So here's the thing. When we go to do this particular perimeter, we say perimeter equals, and we want to add the 3 sides together. So I've got 2 sides here, a 5 and a 5. What I'm missing is this side back here. It's not given to me. So I'm going to have to calculate that side. Here's the nice thing. This is a right triangle, so I can use everybody's favorite theorem, the Pythagorean theorem, to figure out that missing side. So my A and my B are my legs, which in this case are 5 and 5. And then we're just going to plug this into our calculator. And we're going to say 5 squared plus 5 squared is 50. And that's not our final answer. We got to take the square root of that. So we're going to do the square root of 50. The square root of 50. And we get this number. We are going to have to round this number. I'm not going to type that whole number in again. So I'm still just going to go ahead and round to the nearest tenth. I'm going to say 7.1. So I'm going to say that my third side is 7.1. And 5 plus 5 plus 7.1 gives me a perimeter of 17.1. So we're going to plug that 17.1 right here. We know that the distance between the 2 triangles is 10 inches. And we're going to add 2 times the base or the area of a triangle. The legs make the 90-degree angle, so they're the base and the height. We're going to plug that whole thing into your calculator, and you better get 196 inches squared. If you don't, go back and see what you typed into your calculator incorrectly.